All right, welcome to lesson 5 on representing inequalities. Now, this is just a reminder that you may pause, fast forward, or rewind this video at any time. Inequalities may be a familiar topic for you, so you may need to move at your own pace and fast forward as need be. We have split these notes up into 2 different parts because this is a fairly long lesson. Let's talk about what is an inequality. This is a mathematical sentence that compares two quantities. If we look at the example, 2x minus 9 is greater than 0, this means that the expression 2x minus 9, when solved, has to be greater than 0. X plus 5 is less than or equal to 15. This means that the expression x plus 5, when solved, has to be less than or equal to 15 in order to make this sentence true. Now, with equations, there's usually 1 or 2 possible solutions to each equation. With inequalities, there are many values for the variable that make the inequality true. Let's look at the symbols for inequalities. We have this little sideways caret, and this is the less than sign. If we flip that around, it is the greater than sign. If we've got this little sign with a half of an equal sign underneath it, this means less than or equal to, and the opposite would mean greater than or equal to. Let's go ahead and look at some graphs. So if we were to graph an inequality on a number line, the graph of the inequality must show all possible solutions. So what we're going to do is we're going to try to figure out what these dots mean. Okay, if we've got x is less than negative 3, and we ask ourselves, what numbers could x be? Well, if x is less than negative 3, it's got to be negative 4, negative 5, negative 6. So our graph is going to have a circle at negative 3, and then we're going to draw an arrow towards our possible solutions. So towards negative 4, negative 5, negative 6. The next example, x is greater than 6. Again, we're going to draw our circle at the number 6, and we're going to ask ourselves, what numbers are greater than 6? Well, you could tell me 7, 8, 9, 10, so on and so forth. So we're going to draw our arrow towards the numbers 7, 8, 9, 10, so on and so forth. Number 3, x is less than or equal to negative 2. Now, this example here is kind of a different circumstance because x could be equal to negative 2, which means x could be negative 2. X could also be less than negative 2, so x could be negative 3, negative 4, negative 5. Since x could be equal to negative 2, we're going to draw a closed dot at the number negative 2. We're then going to draw our arrow towards the numbers negative 3, negative 4, negative 5. Next one, 4. X is greater than or equal to 5. So x could be 5. It could be any number greater than 5, so 6, 7, 8, so on and so forth. We're going to draw a closed dot at the number 5, and then we're going to draw our arrow towards all of these possible solutions, 6, 7, 8, 9, 10. By looking at these examples, we can see that if we have the less than or equal to or greater than or equal to sign, we're going to be using a closed dot. If we've got just the less than or the greater than sign, we're going to be using an open dot, meaning a dot that's not colored in. Now, let's go ahead and look at some examples. We've got x is less than or equal to 58. Well, in this case, since it's less than or equal to 58, x could be 58. X could also be 57, 56, 55, so on and so forth. So when we go ahead and we draw our graph, we're going to draw our circle at the number 58 on our number line. Then we're going to draw our arrow towards all of the numbers that are less than 58. So 57, 56, 55, so on and so forth. Okay? If we look at the next example, we have y is greater than negative 36. So right away, we know that we're going to draw our circle at negative 36. And since it's the greater than sign, we're going to leave that circle open. We're not going to fill it in. Now we're going to ask ourselves, if y is greater than 36, what numbers could y be? Well, y could be negative 35, negative 34, negative 33. So we're going to draw our arrow towards all of these numbers. Now, here's a couple things to remember. If the variable is on the left side of the inequality, then the inequality sign is pointed in the direction that we need to shade, so in the direction of our arrow. Let's look at this example. X is on the left-hand side of our inequality, which means we're going to draw our arrow in the direction that our inequality sign is pointing. If we look at y is greater than negative 36, y is on the left-hand side, so we're going to draw our arrow in the direction that our inequality sign is pointing. Now, what happens if the variable is on the right-hand side? So what happens if we've got a inequality that looks like this? Well, don't fret, because if it's on the right-hand side, we can actually flip both sides of the inequality as long as we're flipping the sign. Okay, so we can flip and rewrite this so that y is on the left-hand side and negative 36 is on the right-hand side, as long as we flip that sign as well. So what I want you to do is I want you to go ahead and try the next couple examples on your own. You can pause the video and then you can come back to this video as soon as you're ready to check your answers. Go ahead and pause the video now. Go ahead and check your answers. Please see your teacher if you have any questions. And then we're going to go ahead and move on. So the next thing that we're going to go over is how do we write inequalities when we're given a graph. So we're going to look at these graphs below. Oh, whoops, the answer is already written. That's okay. All right, example 7. We see that the circle on the graph is between the number negative 24 and negative 25. So we know our number on the right-hand side of our inequality is going to be negative 25. Okay? We know that our variable is going to go on the left-hand side. And now we have to ask ourselves, if we were to plug in negative 26 here, since that is in the space that's shaded by our arrow, or negative 28, we could also plug in. We have to ask ourselves, is negative 26 going to be less than or greater than negative 25? Well, it's going to be less than, okay? And since our circle is open and it's not filled in, it's just going to be less than. It's not going to be less than or equal to. Let's try another example. We've got a circle that's shaded in, and it's right between the numbers 11 and 13 on our number line. This means that our variable x is going to go on the left-hand side. 12 is going to go on the right-hand side. We know that there has to be an equal to sign because our circle is shaded in. And we have to ask ourselves, if 13 is in the area of our number line that's shaded in, and so is 15, if we were to plug in 13 here, okay, what sign would make this true? Well, 13 is greater than 12, so our inequality is x is greater than or equal to 12. Go ahead and try example 9 and 10 on your own. Pause the video and come back to check your answer as soon as you're ready. All right, let's check those answers. So in this case, our inequality should be x is less than or equal to negative 1/4. And for example 10, x should be greater than 45.5. Feel free to see your teachers if you have any questions on these examples.